Welcome to WACUUMERS Energy World, where we have put forth our ideas on how to leverage the four switches of tapping on natural gas, solar, regional power grids, and other low-carbon alternatives. We have also explored how to manage energy demand and enhance energy efficiency. The energy trilemma of making our energy policies affordable, reliable, and clean also forms our overarching approach in determining the most suitable ideas. Now, let's dive right in. Using IoT technology, we can capitalize on data sharing and analysis to reduce both energy demand and peak energy demand. IoT sensors can collect real-time data on the energy usage of major devices in buildings. Using AI, energy usage trends can be analyzed to detect anomalies that could alert organizations to faulty equipment so that repairs can be swiftly made. Furthermore, IoT smart thermostats can analyze trends in habits and occupancy to adjust the temperature to optimize energy use. Wi-Fi enabled LED lights will also be programmed to follow schedules, motion, or sound to switch on only when necessary. In addition, building owners can partner utilities to exchange data. When energy demand is high, utilities can send signals to IoT devices to temporarily turn off energy guzzling devices. At a district level, IoT can be used in energy storage systems, which are crucial in mitigating the intermittence of solar. Using IoT, the amount of stored energy at different times of day can be customized based on the consumption habits of each neighborhood. These measures will reduce energy and peak energy demand, ensuring the robustness of our power grid and saving energy costs for everyone. Sensitive urban planning and biophilic architecture can also reduce energy demand. Workplaces and recreational spaces can be decentralized and shifted near homes, cutting energy consumption in transportation. Buildings will also incorporate natural lighting and natural cooling, which dissipates heat using on-site heat sinks, and include more nature in their design. This reduces the urban heat island effect and buildings' energy consumption. District cooling and heating systems will also be rolled out, boosting energy efficiency. In particular, district heating can utilize waste heat from district cooling, industry, solar thermal energy, and even data centers. Next up, the integrated poop-to-biofuel and fertilizer facility, which is situated next to a hydroponics farm. This facility collects fecal matter from new water plants and not only provides an alternative source of renewable energy, but also reduces the need for transportation of fertilizer from factory to farm, reducing energy demand. When the power grid is under strain, production of fertilizer can be diverted to biofuel. This is a small example of how integrated buildings can achieve synergy between competing demands. Furthermore, public transport will be promoted as it is more energy efficient than private transport. A tram system can be built, which is 3 times more energy efficient than buses and provides smoother rides, much like the LRT, but without the inconvenience of travelling above ground level.
Singapore will also be more aggressively deploying solar panels. Apart from existing locations, solar panels will be installed on shelters in open-air car parks and shelter walkways. Additionally, transparent solar panels, as counterintuitive as they may sound, can be deployed onto windows en masse. They work by allowing visible light to pass through while absorbing invisible light, enabling every building to produce energy. Let's explore novel low-carbon alternatives to generating electricity besides hydrogen and geothermal. First up, vertical axis wind turbines. As opposed to traditional turbines, these turbines generate less turbulence and are 15% more efficient. More importantly, they can also be placed closer together, saving much needed space in land-scarce Singapore. They can be installed on floating platforms on reservoirs and suitable offshore sites that avoid maritime traffic. Next, we can make use of piezoelectricity, which converts mechanical energy to electricity. This concept can be employed in noisy places to convert sound energy to electrical energy, such as MRT tunnels, or even integrated into the clothes we wear such that body movement can be converted to electricity. We will also tap on regional power grids involving multiple nations in ASEAN to secure our power grid against unforeseen energy disruptions in certain countries. We can gradually phase down natural gas. It may be the cleanest fossil fuel, but it is not clean. That being said, even in 2050, we will most likely retain our LNG terminal just in case of exigencies. To conclude, by empowering firms, households, and individuals with the adoption of new physical and IT infrastructure, everyone can take charge of creating a more sustainable Singapore.